name is Glenn Worth. I'm a solutions architect here at Simio. And today for Simio Sync 2022, I'm going to present the Make, Transport, Replenish template. As an agenda, first I'm going to explain what is a template, and then explain more detail of the Make, Transport, Replenish template, give an overview of that template, and then provide two examples, a bicycle assembly example, as well as a real-time connectivity example. First of all, what is a template? Templates are used to speed up the development process of both design and scheduling models by leveraging a common data schema. Although the schema is set in the template, they can also be modified to match the format of the source data. Most of the detail of the model is added through the data, with very little of the modeling happening through the facility window. The facility window is used mainly for model verification. Why the Make, Transport, Replenish template? Typically, material movements and mostly scheduling models were handled by movement times. They weren't actually handled by transporters. The material availability of those models also were handled by an outside system calculating the material requirements, or they were calculated per order as part of the initialization of the orders. Configuration of tasks were static on the servers, so they're not set up to handle a dynamic product mix. And so this template addresses these issues. First, using the transporters for material movement. Material replenishment is handled within the model using the inventory replenishment policies of Simio. And product-based tasks are captured through the complexities of the model to handle dynamic product mixes. The first component of the Make, Transport, Replenish template is Make. Make has both primaries and secondary resources, similar to the other scheduling examples. The routings table in this example is renamed to operations to match the ISA 88 standard. It also has the movement being mapped from one location that a order to the next location. The tasks of the servers are not defined within the object definitions. Tasks are defined in a child table to the operations table. The name of this table is called phases to also match the ISA 88 standard. The phases has child tables for secondary resources and phase state assignments. There's also bill of materials table. It's a child table of the operations table, but only used for certain phases. The next component is transport. The operations table has a property called vehicle to use to move the entities from one location to the other. As the vehicle property is populated, this vehicle will be used to move the entity from one location to the next. There's also a property called vehicle worker, also in the operation table. So the vehicle worker property is populated. The worker will be required first to pick up the vehicle and move it to location where the entity is. And then the worker will be required to travel with the vehicle and the entity to its destination. The last component of the template is replenishment. In the template, there's a table called inventory locations, where you use to create the inventory elements. In addition, the replenishment policies for the inventory elements are defined in the table. When the on replenishment order process is triggered, the process will create component orders based off the replenishment policies. In addition, component orders can be generated when material is produced against the inventory location. And the inventory locations are mapped to one or many operations that were used to route and make the component orders. To show the use of this template in more detail, I thought we'd start with the bicycle assembly example. But to give a little background of this example to understand where we're coming from. First of all, the original bicycle assembly example assumed that purchase orders and component orders were generated outside the system. And there's a very detailed description of this model located in the examples folder that you should take a look at. Second example that we generated is the update create POs and MOs. In this example, both manufacturing orders and purchase orders are generated based off the material availabilities of each sales order. And these orders are pegged to the sales orders. In the last example, what I'm going to show here is the make transport replenishment example, where both the purchase orders and component orders are generated using the inventory element replenishment policies. Here's a bicycle assembly example of the make transport replenish template. You can see this example is configured very similar to the other bicycle assembly examples, where we have component manufacturing, shipping and receiving, assembly line, as well as assemblers and operators, as well as vehicles. If you click into the resources table, you can see all the different servers that have been defined in this model. In this model, I took a little different approach. I defined all the resources in one table. The employees are defined in a different table. Equipment in a different table. As well as there's a nodes table, a path table, and a path vertices table. You'll notice that the paths in this model are set up with a width of 3 meters. This is set up because the vehicles will move within this model, following the path in free space along the network path. We'll show this a little bit more of this later. Next, we're going to focus on the inventory locations in the model. In the inventory locations table, we have finished goods, intermediate, and raw materials all defined. The raw materials and intermediate materials are all defined here with initial quantities. This is very similar to the material lots table in the other models. In addition, these items have a replenishment policy, as well as reorder point and reorder point quantity. If I focus in a little more detail in a particular product, you can see that our steel top tube has a master inventory quantity of reorder point of 100 and reorder quantity of 1,000. And in addition, we have inventory locations that support both cut and stock that have smaller quantities but also need to be replenished. They have reorder points of 100 and they're restocked up to 500. Next, I'm going to focus on the sales order table. Here's the demand coming into the model. You can see I've disabled all the demand initially, but these are all the different bikes that have to be produced with their release date, due date, and their quantities. So this is an initial demand, but you can see initially I have everything disabled. And what I first want to show is, if I come back to the model and I click a run, I'll start the model. I'll go to the detail later, but if I fast forward the model, you don't think anything would happen. But in reality, just due to the inventory locations that they have to be replenished, the order will generate no manufacturing orders, but will generate a bunch of component orders to support the inventory locations, because when the model initializes, it has many material requirements that it has to fulfill. So it produces these component orders to fulfill those orders necessary. And then the routes of these orders are being driven by, from each inventory location. There are if I click down a little further, there are operations for each inventory location that has to be run through to be able to produce this. Back to this steel tube, for the raw materials coming in here, we just have 2 processes for receiving and then stock, and then the bill of material of the stock will produce a given quantity. And then for these other areas where you have to move stuff from the stock to the cut stock locations, there's other steps that need to be go through. And once it's there, we're going to produce material for that given inventory location. Now with this established, I want to go back to the facility view and run the model again and focus in some more details. So first I start the model. You can see that I have some employees coming over here to the stock, so some orders actually being started here. Once started, you'll see that there's a transporter moves here to basically pick up this item and move it to its destination. As well as there are other transporters that have also started. You can see here, they're going to move back to stock to get the items and move it to their locations. You'll see that the movement is happening in parallel here along the network path. This is because these vehicles are set up to move along network path with collision avoidance. So this enables this to kind of workflow like a lane where multiple vehicles can move along the same path at the same time to be able to get to its destinations. We'll see that more as we go into the model. So if we continue with the model, you can see these transporters move up to stock and they're loaded with the right material. And this order now moves out of stock and it's going to move to an inventory location where it's going to basically produce the item to make that material available. So the blue vehicles are coming from our stock location, so they're fulfilling stock orders, whereas the red vehicles are handling more of our intermediate materials and coming in this area. You can see this stock from the intermediate material came out of the stock location. Now it's moved on to the paint. So this is probably some of the green frame components necessary to be produced. You can see once they're dropped off here, more employees coming over to start working on that item within that given server, be able to produce that. In addition, we have some other activities going on in cut. So again, just because the component orders have been set up and run based off the inventory locations, it kicks off the model. And I want to show the different concepts of those fulfilling those orders without any sales orders being placed in the system. Another item I want to highlight in the model is initially I set up the model, this overall control says use vehicle driver set to false. So I set this to false. I'm going to now set it to true to actually see each vehicle needing a driver. So if I go back to the inventory locations table, let me explain things in a little more detail. So each one of the operations here goes from stock. And in this operation, what next have to go to cut stock. In addition to this table, we've defined both a vehicle, so the stock AMR, that's that blue vehicle is going to move it. And now I've enabled that global control. It's going to actually require a stock operator. And so what's going to happen is for this stock AMR to move, it's going to require an employee. So an employee will have to move it and then be with the vehicle the entire time that it's moving it to its destination with the entity until it's dropped off. So let me show this here. So now it's with enable. So you'll see that more employees are going to be coming out here. First to run the stock, and then some more employees to basically come here to move the vehicles. You can see already there's some vehicles here is being moved with some employees here. In addition, the stock items being moved to the employee as well. So I'll continue here. Now this item's going to be picked up, and once this item's going to be picked up on this vehicle, he will again require an employee to move the vehicle to its destination. Similar to these items as well. So you can see just by having that field where you can enable vehicles to have a worker as well, has dynamically changed how the model's kind of working. Next, I'm going to move over to the sales order table, and I'm going to enable just one order for running the model. Here we have one order for a EcoBart standard green bike. Here's the release date, due date, and the quantity of 12. Move to the inventory location table. We'll see the steps necessary to produce this bike. So if I go to the standard green bike, you'll see all the different processes necessary to produce the bike. First, we have a get material process. And so this is it's going to call out, making sure we write enough material to produce the bike. And so it's going to produce the bike, but then it's going to do a consume. And this consume is handled by the inventory locations to move the material to a material stage location. The next step in the process is our assembly line. In our assembly line, we're going to call out some more consumptions, but these are going to be pegged. And these are going to be the pegged materials that we called out to have moved over to the staging area. And this is what's going to be consumed at the assembly line. In addition, we have our locations based off the locations, what happens. And so if we start down a given line, we'll continue to move down that line because from the assembly node, it could either move to one line or to another. And then once it chooses a line, you have to stay on that given line to basically do this assembly line concept we have going on here. So let me start this sales order and see what happens. And you'll see is as it's generated, it starts to get material, and then as the material is available and moved, we will be able to get the items staged to the next location. Okay, now you can see that now these orders are now the assembly line, and the first order has moved to the mainframe. Now we see here that we have a number of staged material orders coming here, and soon that these staged materials orders are beginning their process to the assembly line to the material stage area. Once the material stage, the material will be available for the mainframe order to start. So here to pick up, increase the speed factor a little bit. You can see here they're moving all in free space along the network path. Each item, I think, picks up 3 different items, and we'll move and provide the material necessary to produce that at the staging area. We'll make it a little faster. You can see different staging materials going back and forth, pick the more materials up, and delivering back to the staging area. So just kind of showing how we can, again, move material through the facility using our inventory locations concepts to basically say, okay, first get all the materials, make sure they're available, and then let's stage them at the material stage so they're available for the assembly line. So I'll fast forward the order and to the very end here so we can see what it looks like on the Gantt chart. So I'll stop here. And we looked at our Gantt charts. We'll see, all right, so we have our 12 bikes being manufactured here, all on the assembly line, so I can zoom in here. And then once they're done here, they're produced, we have 2 packaging orders. Establish a pallet packing. So if I go back to the inventory locations as well, and I see that there's a pallet here. Once there's 10 bikes produced, we have another order, assuming that we'll produce a pallet of each. And so very similar to some rounding. And so this order produces 2 pallets. The first pallet of bikes probably containing 10, and the next one containing 2, but trying to get to the concepts of how the inventory locations can be set up. Support this as well. You can see it's fully waiting here for enough bikes or operators to be available. Lastly, I'll go back to the sales orders table, enable all the sales orders, so we can see a completed Gantt view. So here I'll enable all the sales orders, and I'll go back and fast forward the model. This will be running for a while. Already running is about 30 seconds, but I'll crop when we get to the end. Okay, we've completed a run for about 60 seconds. I think because I have a lot of employees moving around as well. But here, if we go to the Gantt results, similar to what we showed before, I can collapse all. And you can see the different finished inventory products that we produced within the model, as well as all the other manufacturing products necessary to produce in the model, as well as the raw materials necessary to come in the model. So you can see it's a very quick and easy way to configure your model to enable the use of inventory locations, as well as some other concepts of enabling using of vehicles to move material around the facility, as well as configuring both our operations and our phase steps through the data. So each one of these, one that I didn't point out is we have operations, and then if I click on each operations, here are the phases. And the one that I did point out that each phase also has assignments as well. So if I can drill into, let me see the symbol line here. If I click on my phase here, you can see that this phase requires specific assemblers. It also has some state assignments, I think I mentioned earlier, to be able to define what line you should go on. We can define that through setting the line number based off of what location we would do. Mainframe 1, set to a 1, or mainframe 2, it's set to a 2. All right, that's all I have here to cover in this model. Any questions, we can talk to it at the end of the session. Before I show the real-time connectivity example, I first want to explain MQTT. MQTT stands for Message Queuing Telemetry Transport. It is a memory-based messaging protocol that's used in the industrial Internet of Things. It has two main components. It has an MQTT broker and MQTT clients. The MQTT broker manages both the publishing and subscription of messages, and the MQTT clients are set up to either publish and or subscribe to those messages. In this example, the two clients on the right will be set up to subscribe to a message on the topic of position, and the client on the left will publish information on the topic of position. Once that information received to the MQTT broker, he knows what clients have subscribed to that information, and it will publish that information to those clients of the updates of the position. To show the real-time connectivity of the make, transport, replenish template, I have two instances of Simio running, each running the same model. The only difference is this model is running in scheduling mode. It is connected to an MQTT topic that will produce this Simio dispatch. The other model is running in real-time mode, and it will actually consume the Simio dispatch. So to start with, I'll go back to the scheduling model, and I'll run the model. I'll actually fast forward it. So most importantly is generating the data. So I'll fast forward to the end, and when I stop it, it will write information from the sales orders output table to MQTT. So here, I have a dispatch topic showing the dispatch information. Now, if I go to the real-time model, and I run that model, upon initialization, it will actually read from that topic and produce the orders here based off that because it's describing to the model. And this is all set up in real time. So if I go back to the scheduling model and only run it for a very short period of time, well, I just run it for half the time and stop. In doing so, you can see the dispatch has already been refreshed here with the shorter duration amount of orders. So this is how MQTT is integrated between both the scheduling model and the dispatching model. In addition, each one of these HTTP vehicles are also describing and publishing to an MQTT topic. If I go back to MQTT, you can see that command 1.1 and command 1.2 are actually commands going to MQTT topic, basically showing what transport is doing at that current time. So it's showing whether it's stopped, where it's running, where it's go, and what color of entity is running on that transporter at that time. And you can actually see information pertaining to that. So this waiting to pick up something, but they're all receiving red items to the transporter. So it's able to send commands out to, through MQTT from a running Simio model. So in addition, I can actually populate coordinate information as well, going back. And so each one of these AMRs, if I zoom in, I think that's AMR 1. And if I subscribe to a topic for AMR 1, sorry for the jumpiness here, do the right information. I can say, okay, MQTT, and let me define a topic, and let me give some position information. So if I publish this position information, updated this vehicle to its current location based off the position information. So I keep on doing it, it will keep on updating that information. You can change this position by changing the coordinates of the MQTT topic. We'll provide a different location of that vehicle. So this quick example of showing how MQTT can both publish and scribe information into a Simio model, and it can be used for real-time updating of the model. This concludes my session on the make, transport, replenish template. There'll be time now for questions and answers. Thank you everyone for attending.
Hello, Glenn. Good to see you.
Hey, Adam, how are you?
Doing well. It's always fascinating to see what you've been up to. You're always pushing the boundaries of what's possible with Simio. So that was really interesting. Thank you.
No problem.
Okay, we've got some good questions here. So I think the real-time connectivity, right at the end, really piqued folks' interest. So our first question here, what are some additional examples of using Simio with real-time connectivity and some use cases in which real-time connectivity may be valuable.
Yeah, so I think we start with real-time connectivity is establishing, what's the work in process going in the factory. We've done that by interrogating like MES systems and also using PTC, kepware to kind of get at the real PLC tag values, so to initialize the model. And so that's a kind of start with. But here with using MQTT, we kind of open the door to anything. So like a machine status and current product that's running on the machine, machine downtimes while you run it. So there's a lot of options to open up to use the current real-time information, and we're just kind of exploring where we can use this.
Terrific. Yeah, and I think for the folks out there listening, this is really what we mean when we say our digital twin. It's really plugged in, so to speak, to the system. Great to see. Next question we have: are there particular industries or production environments you have identified in which this template may be a good starting point?
Yeah, we kind of focused on in here where a lot of the manufacturing scheduling systems I've seen to start with, they weren't doing like the movement of materials or handling all the ancillary type of processes going on of the manufacturing system. And so what this template kind of models is all those ancillary systems. So moving, if there's hard constraints, moving product through like a clean room class or something like that, we could use this template to kind of model that situation. That also could be used in transporting in a larger type of system, so managing materials between sites. So it really kind of opens the door. It's not really focused in a particular industry, but it's really just kind of, hey, let's provide more capabilities into our routings to include vehicles, and let's use inventory locations to their power to be able to kick off ancillary order processes and so forth. So it really opens us the door to have a data-driven approach to kind of do all this type of work.
Perfect. Yeah, to me, the transport, is almost the key word there. So, if you're out there and you have really material handling intensive systems, this may be a good approach.
Yep.
Time probably for one or two more questions. Can you elaborate a little bit on the relationship between purchase orders and manufacturing orders in these bicycle assembly models? Are manufacturing orders or batches generated in the model from purchase orders?
Yeah, so they're actually, the purchase orders are set up to be more for your stock items. So basically your raw materials coming in the system. So they're kind of unrelated. In this example, it just produces stock at a given amount of time based off the lead time of the material. And then the manufacturing orders in the bicycle assembly, it does do some batching because the manufacturers are just folks in the assembly line, and it produces a row for every bike in that example. And this actually did to the third table, which is the component orders. So all the intermediate orders and also the purchase orders goes through that table as well, to be able to say, okay, these are the components. So it really focuses on that.
Terrific. Okay, I think we're just about at time, Glenn, so we're going to wrap up. But
Okay.
Great to see you. We really appreciate it. Thanks
All
so
right.
much.
Well, thanks for attending.
This concludes this presentation. Please click on the back button to access the next presentation.